This video is the final video for Chapter 10, and it is about composite figures. It does not address a specific section from Chapter 10, rather a culmination of all the ideas we have looked at, and this is why we call it composite figures. A figure made up of two or more figures that we can identify. Oftentimes we look at a shape like the key of a basketball court, and we say, I can't describe that. That's not a hexagon, that's not a circle. But we can divide it into shapes that we recognize. For example, rectangles and squares and trapezoids and circles and triangles. And if we can cut it into multiple figures that we can identify, this is a composite figure, one that is made up of many other figures. The key of today's lesson is that we want to write out a descriptive plan of what we're going to do. That way we know all the parts, we've identified all the things that we need in order to solve these problems. Now, what we're going to do with this material is just look at a couple of examples so that we can understand the idea of how to work with composite figures. And what does that mean? Write out a descriptive plan. So, let's look at this first problem, which I described as the key on a basketball court, and we're going to find the area of the basketball key. So the first thing we have to do is write out a plan. I see that there is a rectangle, so I'm going to put capital A with REC, area of rectangle. And then that would give me this portion here, but I also need this, which appears to be a half circle. So I don't want the area of all of a circle, but half the area of the circle. And I'm going to add the two together. So I write 1/2 area of circle. Now I have a descriptive plan of what I'm going to do. Area of rectangle plus 1/2 area of a circle. The area of a rectangle is base times height. Now we have to remember this is the base and the height of the rectangle. The base of the rectangle appears to be 12 and the height is 8. This gives us 96 feet squared for the area of the rectangle. The circle, 1/2 pi r squared, we need to figure out what the radius is. Well, the diameter comes across from the rectangle to be 8, which means the radius is half of 8, which is 4. So we have 1/2 pi times 4 squared. Now, 4 squared is 16, and 16 times pi is approximately 50, and half of 50 is approximately 25. But we could go to our calculator and go 16 times pi and get 50.26, divide by 2, and we get 25.1. So 96 plus 25.1, and we will add our 96 to this, and we get approximately 121.1 feet squared. And that's our area. Rectangle plus 1/2 circle. Let's take a look at another example, see if it gets a little bit tougher. Now, this is a composite shape, and it also combines what we studied in section 7 about sectors or segments of the circle. Right now what I see is I see a circle and I see a pentagon. And so how am I going to figure out that area? Well, I might look at it and say, I'm going to take out the area of the circle and I'm going to subtract out the area of the pentagon. But that would give me here, 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 and here. That would give me too much. It would give me all of those sectors, all 5 of them. Well, I don't want all 5. I only want 2. So I might put in my plan that I want 2 out of 5 of what I get. I want 2/5 of those, not all 5. All right, so I've got a pretty good plan. Now I have a lot of work that I'm going to need to do here. I have the area of a circle, which hopefully will go quickly because it's pi times r squared, and the radius is 10. So I've got that part nice and set for me with 100 pi. But the area of a pentagon, a regular pentagon, is 1/2 apothem times the side times the number of sides. So that's going to be 5. And the side length I don't know yet, and the apothem I don't know yet. So I look at this and I think, okay, what can we do? And I realize, wait a minute, this is not the best way to do this one. When I drop a radius right here, I can say 360 divided by 5 equals 72. The central angle is 72. And apothem times side times number of sides, I need to recognize that I want to find the area of the triangle and multiply it by 5. And the reason I'm pointing this out is because I have side angle side. I can now say that this is 1/2 side number 1, 10, times side number 2, 10, times the sine of 72. That will give me the triangle, and there are 5 of those triangles. So I can go to the calculator. Sine of 72 is about 0.95 times 10 again, and then divide that all by 2. I've got 47.55. I still have to multiply this by 5. And I end up with 237.76. Well, we'll go with 764. Now I need to do my 100 times pi, so that's going to come out to 314.159. Now all of this is still finding all 5 of the segments. I still have my 2/5 here. There's 100 pi there. Okay, so time to figure out what this is. So I've got 314.159 minus 237.764, and I've got an answer of 76. So I've got 2/5 of 76.395. The key here is to recognize 76.395 is 1, 2, 3, 4, 5. 5 segments. I only want 2 of those. So I'm going to multiply by 2 and divide by 5. And my answer is approximately 30.6. And we'll just put in here units squared. This is one of the hardest examples we've shown all year. Circle minus the pentagon, and then we have 2/5 of what we found. Circle is pi r squared. Pentagon, I abandoned 1/2 apothem times side times number of sides in order to use triangle times 5. Okay. So let's move on then to our final example for this video. We have here what appears to be a trapezoid with a dent coming into it. We've got like this peak here and all these congruent parts and parallel parts. We've got 60 here with an isosceles triangle here, so some more 60 degrees there. Looks like we got an equilateral triangle up there. So we need to find out what we're going to do here. Here's my plan. Area of trapezoid minus the area of the triangle. Whole trapezoid minus that little part. So let's put together the area of the trapezoid. Well, for a trapezoid, I need 1/2 height times B1 plus B2. And I'll come back to the triangle. So 1/2, well, I know B1, it's 18. So right now I don't have a height, I have B1, 18. And B2, because of the equilateral triangle, is technically 6. So I have 6. So I'm missing the height of this polygon. Well, I do have a 30, 60, 90 right triangle right here, and 12 is the hypotenuse, which makes this part 6, and then that makes this part 6 radical 3. So the height of this trapezoid is 6 radical 3. I can put all this together now, and this is 24. Half of 24 is 12, and this becomes 72 rad 3. I've got an answer. Now I can go to my triangle. Triangle is 1/2 base times height, or 1/2 side 1, side 2, sine of the angle. But my triangle, if I go over here, is 6, 6. Drop this down to 3 and 3, and this is 3 rad 3. Because I've got an equilateral triangle. So I have 1/2, base of 6, height of 3 rad 3, which is 9 rad 3. Turns out these both come out with rad 3 in them, so I can simplify this to 63 rad 3. And this would be units squared. Kind of an interesting problem. If I had to, I can still go 63 times the square root of 3 and have a decimal answer of 109.1. And that is my rounded answer, units squared. So again, this all comes down to writing a good plan. Rectangle plus half circle, circle minus pentagon times 2/5, trapezoid minus an equilateral triangle. These 3 examples help us show how we deal with composite figures, and we'll do more in class. That's it for the final video for this level.